Today we are going to do section 9.4, page 861. First, let's consider the product as sums for cosine on the same page. And the proof of it actually is quite straightforward. I mean, as in short. That is, we take the cosine difference formula, okay, and add it to the cosine sum formula, and we notice that the sine part cancels out, so we only have the cosine part left. There's two of them, and the other side would be the difference and the sum being added up in the cosine. And then we divide both sides by 2, and next thing we know, we got the product of sines as sum of cosine. So here's one of the formulas that we already derived. So with that, let's look at example 1. Okay, let me write it down for the same page. So example 1, we have this thing right here, 2 cosine 7x over 2 times cosine 3x over 2. And what are we supposed to do? We're going to turn it into some kind of as a sum. That is, we need to turn it into cosine of something plus cosine of something. And right now it's being multiplied, so we're going to break it into some kind of a sum. To do that, we'll follow the formula that we just finished, okay, which is the product of two cosines is 1/2 of cosine alpha minus b and cosine alpha plus b. So we're going to do exactly that. So this is equal to 2 times 1/2. Let's see, I need to hold this right. 1/2. And then cosine of the difference. So we'll write that down. Cosine of 7x over 2 minus 3x over 2, which is 4x over 2, which is 2x. And then plus the 1/2. Well, we have a bigger parenthesis here. Let's not forget that. And then the sum of it, 7 plus 3 is 10, divided by 2 is 5. And so it becomes cosine of 5x over 2. Why do I have that there? Let me fix it. This is an x. And there's no over 2 either, just 5x, right? Because it's 10x over 2. So it's 5x. So let's write this properly. So 5x. And then the 2's cancel out, and that's the answer. So the answer should be cosine 2x plus cosine 5x, and that is correct. So then we are done with the first example. So let's turn to the next page for the second example. But before that, let's look quickly at how the signs are being added. The sign of alpha plus beta from a previous section equals to that thing. Okay, and alpha minus beta similarly equals to the other thing. And if we were to add them together, then we got a formula for sine alpha cosine beta equals to that stuff divided by 2 again, because we end up with 2 of them here. So we got divided by 2 as the answer. So so that means we have a second formula for this type of thing. And then the next thing we are going to do is do example 2, which is exactly similar to what we have done here. So please do example 2 yourself, except that this time we use the formula right on top of it. Okay, just plug everything in, and that should work out very nicely. Yeah, in fact, we can just look at it right now. Don't even have to do much. So sine alpha cosine beta, as the formula on top says, we can refer to that, is equal to 1/2. And then the 2 angles added up, which is 4 plus 2, is 6, right there. And then the second part of the formula is 4 minus 2 is 2, right there. Is 1/2 is so here, and that's the answer. So please do that yourself, okay? And then look towards the bottom, and we have yet some other trick. Now so far we have been adding up these, like this one on top and the one before that. We have been adding these things up, and that gives us some kind of answer. Now the next trick is we can subtract. No, that's just example 2. Okay, the next trick, look a little farther down. We can subtract these two, and they'll end up with something, because these formulas look different. Okay, to subtract, we slap a negative sign in front of it, and so then when we add this thing to this thing, do the subtraction, and we end up with just 2 sine alpha sine beta. And then here's yet another formula for it. And similarly, there's one more formula. But we're not going to repeat that. Okay, the point is we have a bunch of formulas that will give us all the stuff. So then here are the 4 formulas that's done by either the adding or the subtracting of this stuff. And so therefore, let me see. Here are the 4 product to sum formulas. Okay, they are probably too confusing to remember exactly, so you just look it up every time you need it. Like if you're ever going to need to break, you see 2 cosine of 2 different angles being multiplied together and you need to break them apart into some kind of a sum for some reason, then you apply this one of these things. Okay, so that's that. And with that, let's look at the example 3 on the bottom of the page. Yeah, well, flip to the next page. You can see that it's done very quickly, so please do that yourself, okay, by applying one of the relevant formulas that we need. So let's move on to the next idea. That is, we're going to do the sum to product formulas. So far, we have done the product to sum, which means that we have taken some kind of product to start with, okay, and we have turned it into some kind of addition. That's a multiplication got turned into addition. Now, the next thing we're going to do is turn the addition into multiplication for some way, if you ever need to do that. And you will need to do that sometimes in calculus. That's why we're doing this. So anyway, to prove this thing, we'll prove one of them, okay, and the rest works about the same way. So let's prove sine alpha cosine beta. All right, now to prove this, what is this called again? Sum to product formulas on page 863. We're going to use the formulas we just proved. That is the product to sum formulas that we just did, and use that to finish the proof. To prove it, we can do each one, okay? But we're just going to do one as a sample, and doing one is good enough. You see one, you've seen them all. So we're going to do this one, sine alpha cosine beta, and I'm going to call alpha u and beta v. So copying that formula down, okay, sine alpha cosine beta equals 1/2 sine of u alpha plus beta plus sine of alpha minus beta. So, and the reason I do that, call it u and v, is because I substitute the u and v in there, and then I'm going to call I'll let u plus v equals to alpha, and then u minus v will be called beta. Okay, if that is the case, then what is u and v? So if u plus v is equal to alpha, and then u minus v equal to beta, then we need to do the trick that calculate what is u and v in terms of alpha and beta, and then we'll plug it in right here. Okay, to do that, we add these 2 equations up. We get 2u equals to alpha plus beta, and therefore u then equals to alpha plus beta over 2. And then if we do subtraction, if we do equation 1 minus equation 2, we get that will give us 2v, okay? The u will subtract out, we get 2v equals to alpha minus beta, and then so v equals to alpha minus beta over 2. So that's what u and v is. So if we plug that in here, so u then is alpha plus beta over 2, and v is alpha minus beta over 2, and then we get this equation right here, which is right here, okay? The very first one on this page, where sine of alpha plus beta, see, sine of alpha plus beta is equal to 2 times sine alpha cosine beta. 2 times sine of alpha plus beta over 2. Sorry, I said that wrong, because u is alpha plus beta over 2 right here, and then v is alpha minus beta over 2, which is right here. So that's that. So please do that yourself. Maybe do this one, and maybe do one more or not. But anyway, that is how the sum to product formulas are derived. Okay, but anyway, So just by this quick substitution thing, so a trick that we play basically. So next, let's look at example 4. Write the difference of signs as a product. That is, what is sine 4 theta minus sine 2 theta, and that again is a very short step. So please do example 4 yourself. Okay, you just follow that. Find the right formula to follow, and then follow it, and then a couple of steps later you're done. So that, basically that's about it. And the next thing, example 5, you evaluate the cosine, the difference of cosine, and okay. So what we're gonna do is here's a difference of cosine. So the first thing we do is look at the 8 formulas that we just looked and pick the one that looks right. Yeah, this is the format of the difference of cosines, and that is what it's supposed to be. Okay, so then we just plug the stuff in. Alpha is what? 15 and degrees. Beta is 75. Plug everything in here, and stuff comes out. Okay, and at this point, remember the sine 45 is square root of 2 over 2. Says right here. Okay, and in other words, 1 over square root of 2, which is also square root of 2 over 2. That's sine 45. And then sine of negative 30, that is sine of 30 is 1/2, which is right here. Sine of 30 degrees 1/2. But sine of negative angle is you have to take the negative sign out because sine is an odd function. So the negative sign got taken out, so it becomes minus 1/2, and multiply this stuff, and some answer comes out. So that's example 5. Please do that yourself. And then next, let's consider example 6, and after I clean off the board. So next, let's look at example 6 on page 864. Cosine 4t minus cosine 2t over sine 4t plus cosine 2t. And that is equal to that. And this is an identity that we're about to prove. All right. So to do that, being that this is a minus, there's a minus and plus, if we could turn it into a multiplication situation, then stuff can be canceled out. As it is with minus plus, we can't cancel anything. Okay, because there is no common factor or anything like that. So let's flip it into let's flip it into the sum to product situation, where we can just turn it into a product. Okay, so turning this to product, we look for the relevant formulas used. This is cosine minus cosine, so let's find it. Okay, right here, cosine minus cosine is negative sine of sum, then and then sine of difference. So let's write that down. Copying this thing, then this equal to what is this again? Cosine. Okay, following the cosine formula, that's equal to minus 2 sine. I need to hold my pen right. Okay, that's better. Minus 2 sine alpha plus beta over 2. Okay, this plus this over 2. That's 6. That's 3t. And then sine of alpha minus beta over 2, that would be 4 minus 2 is 2, 2 over 2 is 1, so just sine of t. And then the bottom is a sine plus sine. So let's find the sine plus sine formula, which is 2 of sine and of the sum, then cosine of the difference. So let's do that. So that will be equal to 2 times sine of the sum. Sine of the sum is 4 plus 2 is 6, divided by 2 is 3. And then cosine of the difference. Cosine of difference is 4 minus 2, and then divided by 1 is t. So and so that is that's for the sum, as you can. So let's see where that leads us. The 2's cancel out. Okay, the sine 3t is identical, so let's cancel that out. So we have a negative sign. Don't forget the negative sign. And then sine of over cosine is tangent, so it becomes negative tangent t, and that's exactly what we're supposed to prove. So we are done. And that is example 6. So next, let's consider example 7 on the following page, page 865. And example 7 turns out to use double angle formulas. That's from that I believe is from a previous section that we already had. So please do that one yourself, okay? I don't know why they decided to stick it there. Maybe it's a mistake or, well, whatever. They want you to do it, then go ahead and do it. It's just 2 lines. So that's that. And we have then come to the end of this short section. Now the section is short, but there are quite a large number of homework that I would like you to do. Most of them should be pretty short. The identities might be slightly more complicated. But the rest, you just follow those 8 formulas that we learned, okay, and plug stuff in properly, and then you shouldn't have any trouble coming up with the right answer. So just look up the formulas, probably put it all on the same page like this if you can, so that it's easier to look up. But doesn't really matter how you look it up. Just look it up and that should come up with the right answer. So please do problems 7, 9, 13, 15, 19, 21, 23, 25, 29, 31, 32 to 38. Those are all the identity proofs, the trig identities. They're the most important part of learning trigonometry, in my opinion, that I can think of. Well, yeah, with some exceptions, but we'll get to that. Anyway, so next 41, 43, and 45, 49, 51, 53, then 56 to 63. So that I might do. So you might want to do so much homework in 2 different settings or more, but I feel that they're important to do them, okay? And of course, most of them shouldn't take very long. It's just a matter of plugging in, and the answer should come out right away. So please go do your homework, and afterwards, I want to talk about some of them. So next, let's look at problem 32 on page 866. Where we have this stuff here. Okay, it's hard to tell what it is. So let's start working on the right-hand side, because that's kind of confusing looking. So the right-hand side is going to be equal to 1 minus tangent A tangent B. We'll write that as tangent A tangent B. We'll write it as sine A sine B over cosine A cosine B. Cos A cos B, and then the 1 will also be written as cosine A cosine B, cos B, and then the same thing, cosine A cosine B. And then the bottom is the same thing, except the sign becomes a plus. Everything else is exactly the same. Okay, so let me write that. Now, what is cosine A cosine B minus sine A sine B? Notice the denominators are all canceled out. Okay, so we don't have to worry about that. All we have is just the numerator divided by the numerator down here. And well, cosine A cosine B minus sine A sine B sounds familiar because that is one of the formulas we learned in a couple of sections ago. But that is also on page and we also mentioned that around example 2 on page 862, and I will show you right here. Okay, that is the first one. Cosine A cosine B minus sine A sine B is equal to cosine of A plus B. So we can write that down. So the top equals the cosine of A plus B. If we cancel out all the denominators, because they exist on both top and bottom, so we can just get rid of them. And then the next part, cosine A cosine B plus sine A sine B, is right here, okay, on the same page, where cosine alpha cosine beta plus sine alpha sine beta, that's equal to cosine of alpha minus beta. So in other words, this the bottom will be equal to cosine of A, what was it, minus B. And that happens to be exactly what we were setting out to prove. So this is turns out to be just a one step. You take one step and you basically got to the end of the solution. So that's problem 32. And I should mention that the formulas I just showed you, the sum and difference or something, that's written on page 862, and of course it's also mentioned a couple of sections ago when we went over that. So next I will clean off the board. Actually, I will finish this section in the next video. It's almost midnight here.